Okay, so moving into the mathematical component here, and I'll just stress the top points here. Heat transfer depends on three things. Temperature difference, so the temperature difference between, say, cold water and hot water. Mass of the substance, so if I have a ton of cold water and a little bit of hot water, it doesn't make a difference. So mass plays a huge role. And the type of substance. Okay, so those are the three major things that depend um, on heat transfer. So specific heat capacity, if you're taking a chemistry course, this is going to come up, so you might as well be familiar with it. Specific heat capacity is the amount of heat energy that is needed to increase the temperature of 1 kilogram of particle substance 1 degree. So how much energy is required to move 1 kilogram 1 degree is basically what it's saying here. So here's our formula. All right. So quick breakdown. Small m is your mass, always in kilograms in physics. C is the specific heat capacity. You're given a chart, or will be given a chart on that. Oops, that's not, or you need to calculate in the formula, but you don't have to memorize the values, all right, of water and whatever else we work with. And T is for temperature. All right, and it's always in degrees C. And then EH is your heat energy. Okay, so MC delta T, or delta T is T2 minus T1. So a couple of examples. How much heat energy is required to heat a piece of gold from 25 degrees to 50 degrees? And here's the specific heat capacity is given. All right. So formula, heat energy equals MC T2 minus T1. T1 is the initial temperature always. So what do we have here? Heat a piece of gold. Mass isn't given. So let's just assume 10 kilograms. Well, that's a lot of gold. Let's assume 1 kilogram. All right. Should be given here. So 1 kilogram of gold. Specific heat capacity of gold is given. That's that scientific notation. Final temperature is T2. That's 50. It was initially room temperature at 25. So now you go ahead and use your calculator to determine the value. And I get 3,250 joules of energy. Therefore, you need 3250 joules. Okay, so that's how much energy you'd have to put in to produce with the flame to make that gold go from 25 to 50. A 0.75 kilogram block of aluminum, and again, there's the specific heat capacity for you. At 90 degrees, so it's been heated. It's cooled by removing that much energy. We want to find what's the final temperature of the aluminum. So the nice thing with heat energy, there is only one formula, and I recommend always using T2 minus T1. I find it easier for most of the situations. So heat energy, we removed 5 times 10 to the 4th joules. If we removed it, it's a negative value. All right, negative value. And I'll just put a note on there. We removed energy. That's why we have that negative. Okay, 0.75 for mass. Specific heat capacity of the aluminum, higher than gold. We knew that the original temperature, again, original is T1, was 90. So you have to solve for T2. You need to use your just grade 9 algebra skills here. Divide by 0.75, 9.1 times 10 squared. Do the same to both sides. And this is kind of an upper end question for you with the algebraic manipulation. Okay, cancel, cancel. Punching it in the calculator. I get negative 73.3, and all that's left on this side is T2 minus 90. Add 90 to both sides, and we get that the aluminum is, let's say, call it 17 degrees Celsius. So therefore, final temp is 17 degrees Celsius. Worst thing that happens, if you forget this negative sign, what will happen is this would have been a plus sign, and you would have got 90 plus 73, so you would have ended up with 163 degrees. Oops, I don't know what square is. So 163 degrees. So you'd ask yourself, I took energy away, but the heat went up. So then you'd realize, oh, this must have been a negative value. Okay, and I'll fix it. So it's not the end of the world if you forget this, all right? You got to use common sense. And a lot of you in the 4C usually have a ton of common sense and muddle your way through and realize that doesn't make sense. So it's just a sign error. All right. And that is the show. So there you go. That's the theory was in video 1. The upper end math problems are right here in front of you on the final video. If you can handle that, you can handle heat energy. So good luck, and if you have any questions, let me know.